Let us start with the new chapter, that is the gravitation. My dear students, in ninth class you have studied the Newton's law of gravitation as well as the gravity. What is the basic difference between the gravity and the gravitational force? In somehow the both forces are almost equal, but the basic difference is what? You know, F is equal to gmm by r square. This is the force of gravitation. But if this force capital M, this is replaced as earth, because in this case both the bodies may be any two bodies of the universe and r is the distance between them. But instead of any two bodies, if this is mass of earth, then the force of gravitation becomes the force of gravity. This is in actual the basic difference between the force of gravitation and the force of gravity. Any object which is having mass is always attracted towards the earth, and that is the gravitational force, or you can say the force of gravity of earth. Now what is the numerical value for this force? This force was proposed by Newton and known as the Newton's law of gravitation. According to this law, the force of attraction between earth or any two bodies of the universe, you can say the force of attraction between any two bodies of universe is directly proportional to the product of their masses and inversely proportional to the square of the distance proportional to the square of distance between their centers, between their centers, and we can write it as F. Here this M1 and M2 are two bodies of the universe. They are separated by a distance r. Now we can write the force of gravitation is directly proportional to the product of the masses. This force is inversely proportional to the square of distance. By combining these values, we can write F is directly proportional to M1, M2 and inversely proportional to R square. Now remove this proportionality sign and we can write F is equal to G M1 M2 by R square, where G is a constant and known as gravitational constant. This constant is having a constant value and the value is proposed by this value is proposed or calculated by Henry Cavendish, and the value is found to be G is equal to 6.67 into 10 raised to power minus 11 Newton meter square per kg square. And here comes the definition of capital G. How will you define capital G? So you know F is equal to G M1 M2 by R square when both the masses M1 and M2 are of 1 kilogram and their distance is 1 meter. If they are separated by 1 meter distance, then F is equal to G. This gravitational constant becomes equal to the force. Which force? The force of attraction between these two bodies and the separation between them is 1 meter. So G is equal to the force of attraction between two bodies of mass 1 kilogram each and separated by a distance of 1 meter. So this is the G. And how you will find the formula for G? Take this R on left hand side, you will have FR square divided by M1 M2. So the SI unit becomes Newton meter square per kg square. This becomes the SI unit. Got it, students? You can note down all the points. Factors affecting F, the force of gravitation. What are the factors? Number 1, the masses. If heavy bodies will have more force as compared to the light bodies. Secondly, the distance between their centers. Distance. If bodies are far apart, will have less force as compared to the near placed body. Then it is not affected by shape, size and the medium around the body. And now what are the importance of these are the factors which can affect the force. Importance of gravitational force. You can list them: tides, formation. Tides are due to the attraction of moon and water on earth and moon. Then snowfall or rainfall then motion of planets, satellites in solar system, then solar and lunar eclipse, and many more such points which are based on the force of gravitation. Now one more point is there. What are the factors affecting capital G, whether it is affected or not? This capital G is a constant, and you can say a universal constant. Why this is so? Number 1, not affected by not affected by masses. Number 2, not affected by distance between them. Number 3, not affected by shape, size and intervening media. Rotation of Earth. Hence, it is assumed to be universal constant. Having value 6.67 into 10 raised to power minus 11 Newton meter square per kg square. Note down all these points. Let us solve one numerical, that what will be new force if masses are doubled and, or you can say the masses are 4 times and the distance is doubled. Any case you can consider. For this, F is equal to Gmm by R square. Write new force G m dash small m dash by R dash square, and what is given to you new mass is 4 times. This is 4 times of original mass. Small m dash is also 4 times of original mass. R dash is 2 of R. Put all these values in this equation 2. This is equation 1. Put in 2, you will have F dash is equal to G m dash is 4m, small m dash is again 4m, and this R is 2R whole square. Okay, take the numerical values in 16. G m m by 4R square. This will cancel out 4. This is 4 G m m by R square from equation 1. This is the value of original force. So you will write F dash is equal to 4F. Okay, one more question. Find the force on a body of mass 1 kilogram placed on earth. How you will calculate? This solution will be F is equal to G m m by R square. This capital M is mass of earth, that is 6 into 10 raised to power 24 kilogram. Mass of object is 1 kilogram. Radius, because this is the earth and the body is placed on earth, so you will take the distance as the radius. So this is 6.4, or you can say 6400 kilometer. You can change it into meters. This is 6.4 into 10 raised to power 6 meters. Put this in the value of force. You know G 6.67 into 10 raised to power minus 11 into 6 into 10 raised to power 24 into 1, and R square is 6.4 into 10 raised to power 6 whole square. Take the numerical values one side, 6, this is 6.4 into 6.4 into 10 raised to power minus 11 plus 24, this is 10 raised to power 6 to just 12 minus 12. So this value comes out to be 9.8 Newton. So this is the force exerted by Earth on a body of mass 1 kilogram. Note down these points.